This is a good question to look at as an example of what to do when you're using the sine rule to find an angle. Now, remember the sine rule has that ambiguous case, and the reason for that is when you look at your all stations to central, the sine of an angle is positive in the first two quadrants. That means for acute angles and obtuse angles. So when you automatically go ahead and apply the sine rule to find an angle, it will find you the smallest one, the acute one, and you need to always check whether there's a possibility of it being obtuse. Now, sometimes you'll check and find that it can't be obtuse simply because you can't fit that many angles in. All the angles have to add up to 180 degrees. So if you already know one angle, and then say we found the next angle had a possibility of being 150, well, that couldn't work because 150 plus 35 and a bit is going to be already over 180. There'd be no angles left for the third angle in the triangle. So you have to find that potential obtuse angle, see if it will fit before you decide to accept or reject it as a possible solution. Okay, so this question's got a huge trick in it. Let's have a look. In triangle ABC, well, let's just go ahead and draw ABC. Now, this is not to scale. Doesn't have to be to scale. Just put what you know down in a quick little mud map. AB equals 5 centimetres. And BC equals 3 centimetres. Okay, clearly not to scale, that's fine. And CAB equals 35 degrees and 11 minutes. So CAB, that's this angle here, is 35 degrees and 11 minutes. Now, it doesn't matter that your triangle's not to scale. It literally is there to help you see what the opposite angles are and what you're going to need to use. Okay? Obviously, if potentially there's an obtuse angle that could be in this triangle, then it's not even going to be close to being to scale, so don't even bother trying. Now, the reason this is a really tricky question for a lot of people is they see the 3 and the 5 and they go, oh, it's a 3, 4, 5 triangle, one of those Pythagorean ones, and they automatically go ahead and draw it up like this and jump to conclusions. We have no reason to suspect that it is one of these whatsoever, and if you go down that path, you've got it wrong before you've gone any further, really. Okay, it says all possible values, so you've got to keep your mind open. All right. Now, the sine rule says that we can compare the sine of an angle with its opposite side. Now, the one that we're trying to find is ACB, so we should always put that down first. ACB, that's this angle. Let's call it theta. And let's write out our sine rule. Sine of theta, always start with the thing you don't know, over its opposite side equals sine of another angle that you know over its opposite side. Okay, now just to get the sine theta by itself, obviously it's divided by 5, so if we multiply both sides of the equation by 5, in fact, let's just start by writing 5 in there. 5 lots of sine 35, 11 over 3. Now I have an expression for sine theta. We don't want sine theta, we want theta itself. So obviously what we need to find now is the inverse sine of all of that over 3. Okay, don't reach your calculator till you're here. Okay, now you're ready for it. Let's see what we get. And the answer that I get is 73 degrees, 48 minutes and 22 and a bit seconds. So the 22 and a bit, that rounds down. So let's say it's 48 minutes. Okay, that's my first answer. I can be sure this is a legitimate answer, but there could be another one. So what I'm going to do, always write what you're doing so it's really clear to an examiner what you're thinking. So I'm going to check for an obtuse angle. So let's check 180 minus 73 degrees and 48 minutes. Now what is that going to give us? Well, let's do it. Just do 180 minus answer, and we get 106 degrees, 11 minutes and 37 and a bit seconds. That runs up to 12 minutes. Okay, now check this answer. How do I check it? Well, I say to myself, if I had a triangle that had, if this angle here was 106, could that work? Sure, 106 plus 35 or so, that leaves plenty enough for there to be a possible angle up here. So we're basically just checking that this number plus the angle we already had doesn't add to more than 180. It doesn't, so it's cool. So at the end we say, all right then, always check what they've asked you. We called it theta because that was on our picture. We've just been working with that because it was a little bit easier than writing ACB every time. Check the question what they called it. Therefore, angle ACB equals, and you've got two answers, 73 degrees, 48 minutes, or 106 degrees and 12 minutes.